Hello, class. So the last part of the complex number recorded lectures are going to talk about division with complex numbers, which is the most complicated of all the arithmetic for complex numbers. And then we're also going to talk about the powers of I. What happens if it's I cubed, I to the fourth, I to the fifth, etc. And so let's start with division. And pull up the whiteboard here. And so with regards to division is a little bit tricky. And there are some things in math that they have this standard way of doing things, and sometimes I think it doesn't make any sense. And then they have standard ways of doing things that does make sense. This actually does make sense. And the reason why that is that you'll see that when you do real world analysis, the least number of I's available in the number is the best. And it ends up, at least in the electrical engineering world, we get all these different things called phase shifting of waveforms when you see these I's. And so if you can minimize the number of I's you see in a number equation, you don't have to deal with as many of those phase shifts. So if that made no sense, that's okay. If you ever get into electrical engineering, you would see what I mean. But it might give you a little bit of reason why we actually are asking you to do this. So say like you end up with a complex number that looks like this, and this is division, it looks like a fraction, right? And so the convention in complex numbers is that you never want to have an I in the denominator. You always want to get rid of all the complex numbers in the denominator. And again, for the electrical engineering reasons, these I's add phase shifts. If you put a sine wave in there and when analyze it, and the analysis is just much easier to deal with when you minimize the number of I's that you have. So how do we get rid of the I that's in the denominator? Well, that's one of the reasons why we introduced this idea of a conjugate. If you take and you multiply a complex number by its conjugate, it gets rid of the imaginary part, right? It gets rid of all the I's. And so that's the strategy here. So first step is you find the conjugate of the denominator. And so the conjugate of the denominator in this case would be 4 plus 3i. And then you multiply both the numerator and the denominator by the conjugate. So that would be 4 plus 3i here and 4 plus 3i here. And you see that when you take this, right, that actually the number is 1, right? And remember, you can take any number, and when you multiply it by 1, you're really not changing the value of the number with regards to that. So let's walk through this calculation and see what it gets us. And so this calculation would be, again, you would, need the curvy one, there we go. So you multiply both the top and bottom by 4 plus 3i. And so the way I like to structure it is I'll do the top first, then I'll do the bottom, and then I'll put them together. So let's do the numerator or top first. So here's kind of how I always set it up. So 2 times 4 is 8, minus 3i times 4 is minus 12i. 2 times 3i is plus 6i. And minus 3i times plus 3i would give us minus 9i squared. Yeah. So this is minus 9 times minus 1, so that's plus 9, right? And so when we combine these, we get minus 6i. So 9 and 8 is 17. So this should be 17 minus 6i. Cool. So the next step would be the 4 minus 3i times 4 plus 3i. And when you multiply those together, you get 4 times 4 is 16. Then you get minus 12i plus 12i. And then you again get minus 9i squared. So this would be plus 9. These cancel. 16 and 9 is 25. So the way that this looks would be divided by 25. So here's our new numerator, and here's our new denominator. And in the world of complex numbers, this is the correct format where you don't want the i's in the denominator. I'm not sure. You'll have to see when we get to my lab math. They might ask you to write it in this way. Like I said, we have to take the good with the bad with sometimes the online homework. I will accept either solution when you do it with paper or pencil, but they might end up having you split it up that way with regard to that. So again, process and strategy is you don't want any i's in the denominator. So how do you get rid of the i's in the denominator? Well, you multiply both the numerator and the denominator by the complex conjugate of the denominator. So it's a little bit complicated because you have to do all these steps, but if you kind of keep it organized, it's not too bad. I've used complex numbers throughout my professional life as an engineer, so I find I'm pretty comfortable with it, but I think a little bit of practice definitely will help get you a little bit more comfortable with that as well. So the last thing we want to talk about complex numbers is this idea of powers of I. We call that powers of I. So we'll call this the powers of I. And we'll start with I. And remember, I equals the square root of minus 1. That's our definition, right? And then I squared would be minus 1. And so that's what we have with regards to the definition with regards to that. What do you think I cubed is? Well, if you think about what I cubed might be, I cubed could be I squared times I, right? And what does I squared equal? Minus 1. So you could rewrite this as minus I. And then the last thing is, what is I to the 4th? Well, I to the 4th could be written as I squared times I squared. And that would be minus 1 times minus 1. And so that would be plus 1. So the 4 aspects of this is, I can show you here in the PowerPoint presentation, is that I squared is minus 1, I cubed is minus I, and I to the 4th is 1. And if you continue this, it would repeat over and over again. So there's only 4 possibilities when you have a power with a complex I involved with it. It could be I, it could be minus 1, it could be minus I, and it could be plus 1. And you could see here, I've given you some more examples where I to the fifth is I to the fourth times I, and then that's 1 times I, which gives you I. I to the sixth should be the same as I squared, right? So you have I to the fourth times I squared. I to the fourth is 1. I squared is -1. 1 times -1 is -1, and so on and so forth. So the strategy when you do these is you want to figure out how many I to the fourth are in a particular expression. Because remember, 1 times 1 times 1 times 1 is still the number 1. So that's the strategy. And then whatever's left will end up being the answer. It could be a +1, a -1, a minus I, or a plus I. So let's do a few examples. Say like we have I to the 18th. Well, when you look at 18, how many times does 4 go into 18? Well, it would be 4, right? 16, and there's 2 i's left, right? So we could write it this way. I to the fourth, I to the fourth, I to the fourth, I to the fourth, and then what's left is I squared. And remember that when you multiply variables together with exponents and the variables are the same, you add all this up. So 4 plus 4 plus 4 plus 4 is 16, and 2 is 18. So if you see how that is, it's +1 4 times. And then I squared is -1. So this one would be -1. So that's the theory. And typically you write it this way. You would write it I to the fourth 4 times, and then it would be I squared. And so it would be 1 to the fourth, 1, 2, 3, 4, and then you have that left. Let's do another one. How about we do I to the 52nd? Let's get a big number in here. So what does this actually equal? Well, again, what I do is I'll just do the quick division to see how many 4 I to the fourths are in there. So that would be 1, 4, 12, 13. So it looks like it would be I to the fourth 13 times, right? And so that would be 1 to the 13th power, and that also equals 1. So that's the strategy with regards to that. Let's maybe do one more, and then we're going to call it. Erase this up real quick. So let's try I to the 43. So what would that be? So again, you take 43 and see how many times 4 goes into it. So that would be a 1, and then a 0 with a remainder of 3, right? So we would have I to the fourth 10 times. So that would be 40, and then I cubed. So 40 and 3 gives us 43. So this would be 1 to the 10th power, and I cubed is minus I. So this would equal minus I. So remember, you have 4 possibilities: I -1, minus I, or +1. And again, the strategy is to use the +1 to the I to the fourth. See how many of those go into that exponent. Whatever left, that's going to be the answer with regard to that. So this ends the recorded lectures for section 1.3. And I will stop sharing here and stop the